Good afternoon, everyone, and welcome to the talk. Welcome to India. And although we do not have a very big audience, but still thank you for the persons who are here. And of course, thanks to ITU for organizing this talk. So in this talk, I will present you about a new concept of common user profile on which we are working for quite a few years. And I will just try to extend the definition of the common user profile from what was traditionally discussed in terms of accessibility to more use cases. So to move forward, again many thanks to Julian for the very kind introduction. So as I already mentioned, I am not spending much time on the bio slides. So I studied in Cambridge and did a PhD in computer science, proud picture of me graduating. And I set up my lab in 2016, which works on mainly these 6 verticals: aviation, automotive, assistive, extended reality technology, robotics, etc. And we work with various industry and government bodies. For example, we are part of the human spaceflight, India's maiden human spaceflight mission, doing a project with them, and also work with various industries. On the right side, you will see some bullets on our graduated students who are also spread across both industry academia. Coming to the topic of discussion, the context, that why we need a common user profile. So here is one example. I grabbed a screenshot from YouTube, and here you can see that there is existing subtitle, and also if the closed captioning is turned on, it can become a bit too much or a bit cluttered. But you may ask yourself that how many of us we actually know that we can actually change the settings of the subtitles. We can make it bigger, smaller, and but many times we do not exercise this facility here. Another example, I acknowledge my colleague, senior colleague, Professor Pilar Herrero, who shared some of this picture. These are examples of bad subtitles. So often we talk about providing accessibility, make systems usable for people with different range of abilities. But whatever we study about usability of a system or product, that also equally apply to the accessibility service itself. That it's not only important that we are abiding by legislation by providing subtitle to X% of the media, but that subtitle should also be usable. And this is not only true for subtitle, for any accessibility services. But is it all about subtitle? Of course not. We started with subtitle because this is the most popular and common accessibility service which is presently available. But let us now take a step backward. So on the left side, you will see a video recording. So it was quite an ambitious project we are working for last 6-7 years. That we work with a bunch of students. They are based in Chennai, earlier known as Madras, in a school. And these kids, most of them have cerebral palsy or traumatic brain injury, making them quadriplegic, as well as their speech is impaired. They cannot speak properly. And we make an ambitious effort to make them use existing toys like remote control toys, only using their eye gaze. And here you can see that one boy is flying a toy drone or nano drone using his eye gaze. And the overall aim is to help in their rehabilitation process, that we are making them to help use a robotic system. So this is the present status, which may look a bit gross to you. So we are trying to automate this process using robotic agent to enable them to do fabric printing task, which they are already doing using the present process, only using their eye gaze. On the right side, you can see a picture of my good friend cum colleague, Group Captain Ajit Krishnan. So he is one of the 4 astronaut designates of India's maiden human spaceflight mission. And as part of his MTech research in my lab, we are looking at the manual control of spacecraft. So here you may find a big jump that in one side we are talking about kids who have are quadriplegic or have cerebral palsy. On other side we are showing another application where we are looking at manual spacecraft control. But the important thing is that when we are talking about personalizing media or making it accessible, there is not much difference in the two fields, because in the other field also the person is sorry, can you please mute the laptop? So in the other case also, the person is confined in a small environment. He does not have too much range of motion of his limbs, hand and legs, and still there are he or she wants something personalized for him, and maybe sometimes it can even become safety critical for him or her also. Moving on, here are a set of existing standards in terms of personalizing audiovisual media. I am not going to the standards one by one, and of course it's not an exhaustive list. You can see far more examples, and these are some existing ISO standards. My very good friend Mr. David Forney, he particularly work on one of these standards, like the common access profile, which talks about personalizing accessibility service or even making accessibility services easy to provide for mainstream media. The left one is working of managing user profile. And then from accessibility or consumer electronics, if we move on to the aviation or automotive standard, so this is again not a exhaustive list, but a very relevant list of similar standards for personalizing or rendering audiovisual media from both space science and aerospace industry as well as automotive industry. So for the next few slides, I will just quickly pass through that this is something like the coverage of similar standards, and the difference you will find that these are lot more exhaustive than the common ISO standards on consumer electronics, and many times here you can find that they are much more detailed than the standard consumer electronic service. Like this is a NASA 1997 standards where it was specific about sans serif, and also it is specific about the size of font and the resolution of display. Something about lighting conditions, that here the what we mean by low lighting condition is specified in terms of candela per meter square, and this is about graph display from a military standard, about the rendering quality, and all the distances are measured in milliradians or in visual angle. This is one from the NHTSA standard, which shows the requirement of rendering critical and non-critical information in terms of both textual information as well as non-textual information. And this is about color coding, and here also it's specifying the colors in terms of the wavelength. So in conclusion, what we can see that while many consumer electronic standards, they are advocating for personalizing accessibility, but often they are more works in a much more higher level, or even sometimes they turn into a set of wish list. But in contrast, our automotive or aviation standards, they are much more exhaustive or much more detailed. And this is one study that we undertook, that even staying within the limits of the standards, there is enough scope of personalization even in aerospace or automotive cases, like ITU have multiple focus group on vehicular multimedia, and there also we undertook some study on the width and of graph. So we have enough scope for personalization that whatever we are doing for say people with different range of abilities, we can extend it for many more application. So in this context, this is the technical report last year published on the common user profile by ITU. And what is the common user profile? That it's talk about a minimal set of data that we can use to personalize audiovisual media across a wide gamut of rendering devices and applications, and it will also enable you to carry your personalization across device. So just imagine a situation that you are doing some settings on your mobile phone, and similar settings has been exported to your digital TV or your automotive user interface. Even if it is not exactly transported, but there will be some provision by which you can even import part of this personalization. You need not to change these settings each and every time you are using a device. So here is a brief working or the proposed approach, and again I acknowledge my senior colleague Mr. Nigel Majid, who kindly developed this diagram to explain the concept. The concept is that you will have a common minimum set of profile description, and we will talk about the security in the very next slide. And this profile description can reside on your handheld device, or it can reside only on your device. It need not to be exported to cloud or somewhere, but it will give a metadata structure by which you can share personalization related information for personalizing both the audiovisual media content as well as the accessibility service. So this is the plan of implementation, that we start with the user, and using some user profile creation app, the user creates this profile. This profile can just stay on his personal device, that there is no risk of security issues, that it will not be shared or used by others, because the proposed recommendation is talking only about the format, not about the content. Or if the user has sufficient confidence, it can be also shared via cloud services. And then we will have a set of devices like smartphone, TV, even the automotive car interface. They will have this software or middleware library which can interpret the specific format used in the common user profile, and using that they can personalize the user interface. So we will not instruct people that how to personalize, but we will just trying to standardize that what are the properties of the user interface that can be standardized, and what will be their format, what will be their data range, etc. That will be understandable by a wide range of devices or applications. And this will be the sequence of actions as I just described in the previous slide, that the user profile creation app will only run once, and then the profile can be transported across multiple applications or devices. So when we are describing the profile, of course we have to talk about the variables, and here we took an approach, and a similar approach have already been taken in early 80s when the computing system was pretty nascent, that we will start with the most basic type of primitives like text. Text is everywhere. Then maybe some basic graphical primitives like icons, or if we talk about emerging technologies like haptics, which are the basic primitives. We will define the minimum set of criteria to describe them. Then we have another layer about the higher level primitives, and then the last level we can define the accessibility service. Like for subtitle we can define in terms of a set of say textual primitives, or say audio caption we can define in terms of the sound properties. So this is the present status of the mandatory requirements in the draft recommendation which we are working on. We will have another meeting next month, that where we are making the textual description part mandatory, and the other parts we are keeping at optional requirement, although this will all be discussed in subsequent meetings. And then once you have this common user profile, then there are multiple ways of integration. So one, you can only integrate it in an application level, that you are developing a CUP enabled application, and you can then run it on multiple devices. I will show you example. It can be at the browser level, that all web pages will be enabled or personalizable by common user profile, or in the best case it can be at the operating system level, that you have your Android profile or your Apple profile when you are using such a device. Right side I put an example of a very one-to-one mapping as part of old European Union project we undertaken. But the recommendation will not tell you that how you are doing the personalization, because that will have restrictions from the device as well as the applications, and we will stay within the limit imposed by the device and application. But we will only talk about define this set of properties which is understandable by multiple systems. So this is further one example of the one possible example. This is not the only example. This is one possible example that where we define the CUP as an XML file on the left side, and then there is this interpreter marked in green in the middle of the slide, which define the CSS file or cascading style sheet file, which can define the color contrast, font size, etc. Here we have reverse contrast and bigger font size for the person based on the CUP definition. And then we can see some more examples. So this is one example from our space science domain that which we already implemented when we make a VR virtual reality cockpit of a spacecraft. And this common user profile need not to be always related to the user's explicit requirement. For example, there was some NASA study which shows that our readability decreases even when the G force is only as high as 1.4 G. So if there are the context demands, then also we can use the common user profile to turn on personalization. Like most of the smartphones nowadays, they have automatic brightness contrast that from inside, if you go outside, the screen brightness will automatically increase. So something similar that this common user profile can also be used to initiate context sensitive personalization. So these are some more examples that where the same user interface is rendered in different font size and color contrast, and these are for a Unity virtual reality application. And same thing here we are showing for other applications. So on the left side, this is a web-based application, and based on the different rendering or device, we can change the font size, button size, inter-button spacing, etc. And similar personalization we can also do for an Android app. So the idea is that you will have only one profile, and the same profile can be used to personalize your web apps, Android apps, or maybe a virtual reality application, if we have a consensus on the definition of these variables. And this is more ambitious use, rather something more from my PhD research, that if we have such a profile, we can also use it as a training tool for designers. Say for example, this is a screen again I took from our European Union guide project, where we try to make a video conferencing application using digital TV, and we can simulate how the same interface will be seen by someone having red-green color blindness. We can simulate that if someone also has diabetic retinopathy, you need not to know what is diabetic retinopathy, what its effect, but you can visualize the kidney-shaped scotomas on the screen. And also we can show that if someone has tremor in hand, how he or she can, his mouse cursor trace will be on the screen when he or she is trying to press this small arrow key on the right. And from that, it can also work as a accessibility teaching tool for designers, that they may not know what is macular degeneration or what will be the effect of Parkinson's, but they can visualize the effect of impairment on their design. And that is also possible, that if we can define the profile like that. So in conclusion, we looked at different applications and also standards in terms of aerospace standards, automotive standards, which are more detailed. And of course, we also looked at the personalization or user profile related standards, which exist in both ITU and ISO. And on that concept, I tried to advocate this idea of this common user profile, that which only talks about standardizing a set of definitions of describing user interfaces. And the aim is to further improve the conformance with UN CRPD, making systems not only accessible but also personalizable, and increasing the range from accessibility to inclusivity. So with that, I will stop talking. Thanks again for the audience, and if anyone has any question, I will be happy to take. Thank you.